Here we are going to have a look at the graphical representation of motion. A boy starts to move from rest. A boy starts to move from rest and moves 2 meters after the first second, the second, and the third. On the 4th second, he stops until the 6th second. Plot the graph and find his velocity, if any. Now here, we first need to tabulate what's happening first, so that we can have the mathematical coordinates to can draw the graph in presenting what's unfolding here. And that being the case, you will have the time. Your time will be here. The time will be here. Change in motion will be here. The time is in seconds. This in meters. So what you have. And then he starts from rest. After the first second, he has traveled two more. On the 4th second, this guy is still at that position of 6 meters. Now, we can write that. Draw a Cartesian plane. And we agree that the x-axis will be a time. His movement is depending on the time in seconds. And you have meters here. And that is displacement. And here, this will be the seconds. That will be the first second, the second, third, and then you'll have change in the displacement. Now, for the first one there, at t0, the guy hasn't moved. At t1, the guy has moved 2 meters. At 2, the guy has moved 4. At 3, the guy has just moved 6. At 5, the guy at 4, the guy is still at 6. At 5, the guy is still at 6. Let's 6 the guy still. Now we can join those points. And join our points. And then we can rectify what we did here. We can rectify what we did here. Those points are on the line there. Now, we can say that at 3 seconds, the guy has moved 6 meters. At 4 seconds, still find him at 6. At 5, you still find him at 6. This means that the guy here was stationary. We can analyze and say the boy was stationary here. And here the boy was moving. Now, if you look at that graph, if we can get the slope of this graph, let's see what happens. You know that the slope from here to here is 0. The slope mathematically is changing y, divide changing x, which is y2 minus y1, x2 minus x1. Now we can choose any here. We can choose any here. Let's choose this ones here and call that x2, call that y2, call that x1, call this y1. Therefore, we can say x2 here, x1 there, y1 here. Sorry, y2 there, excuse me. Now, y2 will be 4 minus y1, say 2. And then the x2, x2 will be 2, x1 will be a 1. 4 minus 2 is a 2. 2 minus 1 is a 1. That gives us 2. Now let's have a look at the units. The units on the y here is that in meters. And the unit on the x is a second. Time, of course, is meter per second. That gives us meter per second. And you can appreciate that this is the unit for velocity. So we can conclude that the slope of the gradient of displacement versus time gives you velocity. We can conclude that the slope, the gradient of displacement versus time yields velocity. Now, let's go to another one. Let's have a look at this graph here. And see what's happening here. We have here velocity in meters per second. We have time here in second. And let's see that is about 10. And that will be 0 here. And we can put our time. Say here, time is 4, 2 there. 8 seconds there. 10 seconds there. 12 seconds there. Now, if we have to interpret what is actually taking place here, I hope you appreciate that at t is 0, the v of an object is 0. That as time increases, v increases up until it reaches 10. Time goes on, v does not change, it's constant. V is constant. V is constant between this time interval between 4 and 8. So we can say from 4th second to the 8th second, V is not changing. Or you can say V is constant. And that is 10 meters per second. Now, between 0 and 4, V is changing there. Now, we can find the change in V. Change in V over the time, but you can recognize that this gives us the acceleration. Therefore, by definition, acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. That's what we have there. So we are going to choose 4 and 0 as our coordinates to get the change in the velocity. Now you're going to choose 0 and 0, this point here, and that point there, where x is a 4, y is a 10. Choose these two coordinates here. I can call that B, call that point C, call this point D, call this one E, and then we can call that A, and then you said that is B. Now changing V, T, this will be 10 minus 0, 4 minus 0. That is 10 over 4, which is 5 over 2. The units are meters per second, and here second. The unit there, meters per second, and the unit here for 4 is second. The unit there, meter per second. Now this gives us 2.5 meters per second squared, which is the unit for acceleration. Therefore, the slope of, you can conclude that the gradient is still is of course the slope of velocity versus time graph yields the acceleration of an object right. That's what we have. Now we are going to have a look at actually what happens here. What happens here? What actually happens there? I want us to concentrate on this part only. I want us to concentrate what happens underneath there. I want us to concentrate what happens under the graph here. Now look what's happening there. From here, from the 4th second here, down there, see there's an area here, this shaded one here, but this AB and that 4 give us a triangle. And if we move down, we get a rectangle, we get another triangle there, and another one there. Now let's see what happens if we have to calculate for the area of rectangle only for a start. Now, the area of a rectangle is the length multiplied by the breadth. From here to here is 4 seconds. From here up to B is 10 meters per second. Now let's have a look at what's amazing here is that the second will cancel with the second there. We remain with meter, and 4 times 10 is 40. That's 40 meters as your answer. Now, this teaches us that the area under the graph of velocity versus time gives you the displacement, because that's a unit for displacement. Therefore, you can conclude that the area under the graph of velocity versus time is their displacement. Having arrived at this conclusion, you realize that this object from the 4th second to the 8th second was moving at the constant velocity. No, there was no increase in velocity. But from the 8th second to the 10th second, you see you're going down from 10 to 0, you're moving down from 10 down, you're moving from 10, you're going down. And then you agree that this object here, V will be 0, which means at D, the object is stationary. And now what is of interest is what happens between D and E. Now, according to that, you know, in the Cartesian plane, you have Y here, you have negative Y there, you have your X there. So if from D to there to E, the vector is negative, it means the object changed direction on the after the 10th second. It changed direction, moved in the opposite direction. It moved in the opposite direction. Now, it's easy for you to calculate the distance that the object has moved from A to D, as well as the displacement from A to D, as well as calculating the distance that an object has moved from point A to point E. And interesting enough, you can also get the displacement that an object has moved from A to E. But don't forget that this is a negative vector. Therefore, you must take the area of a triangle, the area of a rectangle, the area of another triangle, and you minus the area of this if you talk about displacement, because displacement is a vector. So direction is of importance here. This direction here was negative, that direction was positive there. Okay. We will look at questions based on what we have learned here. Enjoy and goodbye for the day.